Hello everyone, in this video we're going to see the solution to the Codeforces problem Captain Flint and a Long Voyage, which is problem B of Codeforces round 660 division 2. Okay, so in this problem it's given that we have an integer x, and x has n digits, okay? And from x we're making an integer k, and what is k? K is simply the concatenation of binary representation of digits of x. So like it says in example, if x is 729, then n is 3 because there's 3 digits in x, and k is this. So first we take 7 and make the binary representation of 7, then we have 2, we make the binary representation of 2 and then add it, then we have 9, and so we make the binary representation of 9 and then we add it. So that will be our k. Now we got k from x by just simply concatenating the binary representation of each digit of x in order. Now from k we have to get a new number r. How do we get r? Simply we've gotten a, now we simply have to remove the last n digits of k. With that we have r. So how are we getting r from x? Very simple. We have x has n digits. From x we make k, which is like it says the concatenation of binary representations of digits of x, and then we remove the last n digits. For example, this is k, right? So how will we get r? N is 3 here. So if I remove the last 3 digits, so the remaining part will be r. Now what do we have to do? So we're given n, so we're given the number of digits of x, and now we have to find an x such that r is maximum possible. And not only that, we have to find the minimum x with which r can be the maximum possible. Okay, so some examples are given. For example, 1 is given as 8 and 3 is given as 998. Now let's just look at one thing. Okay, so suppose we want to maximize k. Right now our goal is to maximize r, but leave r. Suppose I want to maximize k, and suppose n is something like 5, or n can be anything. So what should be the best x so I can maximize k? So the best x can be 9 n times. So if I have n is equal to 5, so I'll just put 9 5 times. 9 9 9 9 9. Okay, and with this I can get the maximum k. Why is that? Because if I take 8, then I'll get 1000. But if I get 9, I'll get 1001, which is the maximum 4 digits possible with the binary representation of 1 digit. Suppose if I have 7, then what will 7 come to be? As you can see, 7 will come 111, right? So this will be 111, and 111 is lesser than 1001, and 1001 is greater than 1000. So that means that if I take 9, then that is better than taking 8, and that is better than taking 7. So that's why if we take 9 for each digit of n, then we get the best k possible. So best k will be what? 1001, and this 5 times. So 1 2 3 4 5. So this will be the best k, the maximum k possible for n is equal to 5. So for any n, if I just write 9 n times, then I'll get the maximum k. But we're not after k, we want r. So what is the difference between k and r? We're simply removing the last n digits of k to make r. So meaning that the last 5 digits will be removed. Last 5 digits as in these 5 digits will be removed, right? So suppose I remove these 5 digits, okay? So this is what I'm left with, right? So this is anyways the maximum r possible, because we started with the maximum k possible, and so if I remove even the last n digits, this will be the maximum r possible, okay? So this is sure that this is maximum r. This is maximum r, and we got this from 9999, right? But can we get the same r from a lower number than this? So let's just check this. Let's just check that. Okay, so I have this as my k. But anyways, if you can see, I'm removing the last 5 digits, right? So these 5 digits don't have to be the same. I can change them to lower this number. So these 5 digits are, let's just mark them as star. 1 2 3 4 5, because anyways I'll remove them, right? So these 5 digits, I'll just mark them as star. 1 2 3 4 5. Okay, now instead of these 5 digits I can put anything, right? So I can put 0 0 0 0 0, but what that will do is that will increase our x. We want to decrease our x. So what we can do is we can take these 4 digits and we can make them 1. So we can make them, let me just, yeah, we can take these 4 and we can make them 1000. So what will that do? That will have 1000 and that will make this 9 as 8, right? Now, can we get any lesser than 8? No, because if I have 7, then it will be only 3 digits. So it will only be 111, right? And we'll be removing that. So we'll get one number lesser. Okay. So 8 is the lowest possible from 9. So I'll make this 1000. So that will make the last 9 as 8. So that is lesser. Now I can make this as 1 and keep this as 99998, or I can change that to something else. So suppose I change this to 8. So if I change this to 8, meaning that this will be 1000, meaning that this is being changed to this, right? And anyways, the last 5 digits are being changed and this remains the same. So the R remains the same. So what we did is and you can see that this is lesser than 999999. Okay. So what we did is we saw that we have to remove the last n digits, right? So instead of the having 9 at the last, we can get a number lesser. Now, why can't we get any number lesser than 8? So I'll say again, suppose that, let's just remove this for a while, and suppose that I have 9999 and suppose I have 87. Okay, so I get 10001 and again I get this 3 times and then I get 8, so that is 1000, and I get 7, that is 111. So you can see that this is one number lesser than this. Okay, x is lesser, we're getting x lesser, but with that r is also getting lesser because k is getting lesser, right? Now if we remove 5 digits, then it will get even lesser. So if we try to lower it from 8, then our answer will also get lower, but we want our answer to remain the same, and then we want x to get minimum. So like it says, we have, if there are multiple answers of x, we have to find the minimum x. Okay, print the minimum integer x such that r is maximum possible. If this was not there, we could have simply put 9 n times. Okay, so let's look at another example. So suppose that n is equal to 3. So what we can do is we have to remove the last 3 digits, right? So what we can do is we can do simply 998. So that means 1001, 1001 and 1000, and I'm removing these 3 digits, and so this is still the maximum possible. Now how did I find that I'm getting 2 9 and 1 8? So that is very simple. Okay, first let's see how many 8s we'll have. So we're removing n digits. Okay, so let's say int k is equal to n by 4. Why 4? Because for each 4 digits which we're going to remove, so I'll just write that down. For each 4 digits we will remove, we will have 8 in x. Okay, like I said, if we're removing the last 4 digits, so these 4 digits will be what? 8 in x. Okay, so for each 4 digits we'll remove 8 in x. So for each 4 digits that we're removing, we'll have 8. So if int k is equal to n by 4, so simply at the last we'll have 8k times. And one more thing, if n% 4 not equal to 0, then we'll have 8k plus 1 times. Okay, now we already have k digits out of n. The remaining, like it says, x has n digits, right? Now we've already found the last digits, so the rest of digits will be 9. Okay, so let me move to the code once, and then you'll have a better understanding. So okay, yeah, so this is the code. Like I said, first what I'm doing is I'm doing n by 4 and I'm representing it as a string, and so at the last what I'm doing is I'm adding 8, but here 8 is being added to the front. I'm reversing the string at the end, it's not a problem. Okay, so and if r is not equal to 0, meaning if n% 4 is not equal to 0, I'm adding one more 8, and then whatever is left from n, because it has to be of n digits, then whatever is left I'm adding 9 for that. And then because my string is reversed, I'm reversing the string and I'm printing the answer. So that's all guys. If you have any doubts, just put them in the comments. So that's all guys. Thank you.